And the answer, of course, to that last question is yes, they do affect each other. This is a very important concept to get, and it's the idea of overpumping a well and how it affects the water table. So you can see in the first diagram there, in the top diagram, we have a fairly level water table, and we have a well that's maybe producing for that small farmhouse, and then there's another well on the right that's being used as probably irrigation well, and there's a site of a deeper well that's been set, a high capacity well. So the difference between wells, is diameter. You can get standardly a 4-inch well, and then it goes up to as high as you can get a permit for. Well, what ends up happening is we pump water, and in pumping the water, we lower the local water table. So if you do that, you're going to create something that's called a cone of depression. And that cone of depression will in fact cause the wells that were previously flowing wells to become dry wells because the water table gets lowered to a height that's below the depth of the previously flowing well. So this happens in lots of cases where instead of having wells that are owned by the same person as maybe in this diagram, you have perhaps a nuclear plant that has got a permit to sink a well and it's pumping so much water that entire cities lose their water supply because their wells aren't deep enough to get into the newly lowered water table created by this cone of depression. So this is, again, it has lots and lots of variables, but the basic idea here is that overpumping anything, any type of water table, is going to result in a lower water table, which may not be able to be reached by people who depend on it. So this is something that needs to be considered by any jurisdiction that's allowing water to be pumped, and one of the main reasons that a scientist needs to be involved in this type of issuing of well permits.